Welcome to this presentation on the Place Susceptibility Index, or PSI, brought to you by the Inform-Africa project under the DSI Africa Consortium. I am Professor Olanrewaju Lawal from the University of Port Harcourt, Nigeria. I'll be guiding you through this important topic that helps us understand and measure community vulnerability. In today's presentation, we'll cover several key aspects of the Place Susceptibility Index. We'll begin by exploring what PSI is and its fundamental definition. Then we'll examine the various data sources required for its implementation. Following that, we'll delve into the methodological approaches used in PSI analysis. Finally, we'll discuss how to interpret PSI results and their practical application in public health scenarios. The Place Susceptibility Index, or PSI, is essentially a social vulnerability index that provides a quantitative measure of how susceptible different locations are to adverse events. This powerful tool helps us understand and measure a community's capacity to prepare for, respond to, and recover from disasters or emergencies. By quantifying place-based susceptibility, PSI plays a crucial role in preventing human suffering and reducing financial losses during catastrophic events. It serves as an essential metric for decision makers and planners in identifying areas that may need additional support or resources during times of crisis. PSI is a relevant indicator for measuring the capacity of a group of people or a place to anticipate, cope with, resist, and recover from a hazard. It is a critical tool for ministries of health, public health organizations, disaster and emergency management agencies, humanitarian agencies, etc. Such agencies can utilize PSI in preparation for infectious disease outbreaks or natural disasters, helping them anticipate and prepare for the quantity and distribution of resources required in various locations. This is particularly important as high negative outcomes are often found in places with high susceptibility. To develop PSI, reliable and diverse data sources are required. These must be able to capture the socioeconomic and demographic characteristics that may reduce or increase fatality, human suffering, and financial losses across communities or places. Relevant variables to capture this may be obtained from 1. Population census often has a vast array of variables relating to household and individual characteristics. 2. Survey data is another valuable source of data. This is useful in complementing the census data. Surveys are often more frequently done than census, thus allowing them to capture relevant variables for PSI. 3. Generalized and specialized sources. These include health statistics from ministries of health, socioeconomic and demographic data from the National Statistics Bureau, crime statistics from security agencies, and disaster and emergencies data from the Emergency and Disaster Management Agency. Furthermore, modeled data derived using various statistical techniques, which fill the gaps in survey and census data, could be used. What are the different approaches to developing PSI? Let us review some of them. The approach implemented by Qatar in 1996 is one of the most used approaches. The first step in this approach is to identify the susceptible population. Qatar suggested a set of predefined themes for which one should look for representative variables. These themes are socioeconomic attributes, household composition and disability, housing and transportation, and minority status and language. Once this definition has been made, the next step is the acquisition of the data that captures these themes from various sources. After the acquisition, the computation of susceptibility scores is conducted, which involves normalization, which is conducted differently depending on how the variable impacts susceptibility. The last step is the computation of the PSI, which is the arithmetic sum of the scores for the themes or all the scores. Another approach is the one adopted by Lawal and Arokoyu, 2015, and Lawal and Osayomi, 2021. This approach introduced feature extraction to remove redundant variables. The approach is like the Qatar 1996 approach, but more expansive in variable selection. More variables are selected with or without theme identification. From this compendium, correlation and factor analyses were used to remove redundant variables and identify dimensions within the dataset, respectively. This refines the variable selected for the PSI computation, thus enhancing interpretability. The PSI is computed as the arithmetic sum of the scores from the selected representative variable after the factor analysis. To interpret the PSI, the computation must be conducted to reflect that a higher PSI value indicates higher susceptibility to harm, hazard, disaster, or health emergencies. Thus, a lower PSI score shows that a place is less susceptible and has a stronger coping capacity. This can reveal how characteristics such as socioeconomic conditions, housing, transportation, and access to resources influence a place's ability to respond and recover, or how much worse off the place could be in situations of emergencies or hazards. How can we use this tool or index? PSI is valuable in public health, supporting planning, preparedness, and response. It could support identification of communities most at risk of hazards, disasters, public health emergencies, preparedness for infectious disease outbreaks and natural disasters by prepositioning of resources, allocating resources more effectively to vulnerable areas, identification of how inequalities, poverty, housing, and transportation increase susceptibility, targeted interventions to reduce harm and enhance recovery capacity. In support of optimization of resource allocation, PSI can help answer where should we prioritize resources for preparedness and response, and where will there be a need for tailored intervention. For capacity assessment, PSI could help answer the question of how PSI components influence hazard, emergencies, or health outcomes. Furthermore, PSI could support the identification of capacities that could enhance positive outcomes during emergencies. PSI supports the evaluation of places and communities, thereby enabling place comparison, assessing the effectiveness of interventions, and facilitating targeted susceptibility reduction. In conclusion, PSI can quantitatively describe the relative susceptibility of a place or community. It is a useful decision support tool for ministries, departments, and agencies of health and social welfare, as well as disaster emergency management agencies. It is valuable in supporting preparedness, response, optimization of resource allocation, and assessment of intervention impact, among other benefits. Therefore, development and utilization of PSI are vital in supporting public health decision-making. Special thanks go to the NIH and DSI Africa for funding this project. I would also like to express my gratitude to the entire Inform Africa team for their support and collaboration in the development of this tool. Thanks for listening.